Let's start with the names of bones. Here are the leg bones of 4 different creatures. All 4 of them, human, bear, horse, and camel, have pelvises. And the first bone we study is the femur. There it is on a human. Let's see it on a bear. Same bone, same position, very similar. A couple points. At the bottom part of the femur, where it reaches the knee, there are condyles. They're sort of round shapes. And at the origin of the femur, there's the great trochanter. It's a handle that muscles are going to grip. Horse has a femur, shorter than ours, and the extinct camel. The next thing is that there's a kneecap. Technical name for it is the patella. When it comes to the lower leg bones, the big heavy bone is the tibia, and then there's a thin bone on the outside called the fibula. That's made to anchor muscles. Bear has exactly the same thing, tibia and separate fibula. A horse has a tibia and a fibula that fuses right into the tibia. It doesn't even show up down at the ankle, whereas this extinct camel only has a tibia. Hoofed animals don't have such obvious fibulas because they can't wiggle their toes and move their feet around like we can. The next group of bones is the tarsal mass. 7 bones in us, same thing in a bear, and beyond them, the metatarsals, which make up the body of the foot. Horse has the same parts, but simpler. They have a tarsal mass and a single metatarsal. The camel has that tarsal mass, and an important bone worth naming is the calcaneus, the heel bone, and they have a split metatarsal, as split-hoofed animals do. So there they all are, with labels, and with fewer labels, and with no labels, so that we can see them in their naked glory. Now let's simplify the hind leg bones. We know that the pelvis angles back, and that it's 3-dimensional. The knee wedges forward, the ankle wedges back. That's about as simple as we can get and remain anatomically true. Now let's look at the hip joint and the knee. Start with the hip joint. There's a socket built into that hip, and the femur has a ball that fits into the socket. So it's a ball and socket joint. That means that it can swivel around. The knee is a hinge joint, but not fixed like a door hinge. It's a sliding hinge joint. There's the femur, there's the patella, that's the kneecap. The patella pulls on a strap to lift the big lower leg bone, the tibia. That's a straightened knee. When the knee bends, it moves into an acute angle. Notice that these blue lines all point in the same direction. Those are X lines, and on a wheel, X lines stay consistent. Knowing that can help make drawing hinge joints a little less threatening. Now we'll study the ankle. We could study up to 20 bones in a foot, but it's not necessary. It's better to group them, so this is a simplification. As you recall, creatures with toes have 2 bones in the lower leg, the tibia and the fibula, that grip the ankle. The tarsal mass and the metatarsals make up the body of the foot, and the 2 most important bones in the tarsal mass are the talus, which is a spool bone for that fixed hinge joint, and the calcaneus, which is like a lever handle. The lion's foot has all the same parts, and the horse's foot has many of the same parts. It's a simpler foot. There are fewer bones, and they're fused together. So here's how we categorize them. We plant our feet on the ground, so we are plantigrades. Creatures with claws walk around on their digits, so they are digitigrades, and we call their feet paws. Animals that walk around on a toenail are ungulates, and we call their feet hoofs, or hooves, or hooves. That's the ankle and foot. Hind leg muscles. Let's begin with a human leg and look at the major groups. The hip group, which consists of 3 muscles, the gluteus maximus, the gluteus medius, and the tensor muscle. The thigh group, made up of the quadriceps, the hamstrings, and the adductors. On a human, these are obvious because our upper legs aren't buried in our body like an animal. Lower leg has the calf group and the extensor group. Those are the major groups. Now let's compare them to animals. A bear is a plantigrade. It plants its feet on the ground like a human, so it has something in common. But let's put a horse in there so that we have a range. And there's that hip group. The arrangements vary, and they can get complex. We're simplifying. That's the gluteus medius, gluteus maximus, and there's the tensor. In the upper leg, we have the quadriceps, the hamstrings, and since this is an outside view, we're seeing mainly outer hamstrings, the calf group, and the extensors. Here's what the calf group does. It pulls on the heel and lifts it. The extensor group lifts the foot. Books can confuse you when you study names. 4 books may use 4 different names for the same part. Here's an example. The pelvic crest may be called the pelvic point, the tuberosity of the iliac crest, the tubercoxae, or the anterior superior iliac spine. If we're trying to impress people, we should learn all those names. But if we're trying to master drawing, any name will do. What we care about is that it's the wide point of the pelvis. Pelvic crest is fine. But most names are consistent. The ischium is the ischium. We don't need to distinguish it as the ischial tuberosity. We do need to know that it's the backmost part of an animal's haunch, and almost always narrower on the X measurement than the pelvic crest. There's that great trochanter of the femur, the tibia, and the thin fibula that runs alongside it. There are inner hamstrings that we haven't paid much attention to because on animals they're hardly visible. The calf group has an Achilles tendon that pulls on the heel. Some animals, a few reptiles in particular, don't have kneecaps, but that's okay. Their quadriceps connect directly to the tibia, and we find all sorts of variations on the same basic parts. Let me show you another thing about knees. It's best to simplify them, but they can confuse you because of their internal structure. A horse gives a good example. What is the bump that makes the knee? The obvious answer is the kneecap, the patella. But there's a fat pad above it that can look like the knee. And in a slightly flexed position, the condyle of the femur looks like the bump of the knee. And on the tibia, the tuberosity known as the nose of the tibia can look like a kneecap. That's a side view. Let's put it into 3D. Patella, fat pad, femur condyle, tibial tuberosity. 4 potential knees. Which one do you use? That's a choice. You can learn them, then accent them, or play them down as you like. The surface of an animal is determined by the substance inside. That's why we develop X-ray vision if we're going to paint and draw with authority. Now let's work on form analysis. Edward Muybridge, that is how you spell his name, took this photograph over 100 years ago. It's gritty and high contrast, and you might not think it's good to study from, but it's great to study from for exactly that reason. There's no temptation to copy what you see. Instead, we analyze using what we know. Here are some new observations about hind legs. There are plane breaks on a leg at the heel, and the patella makes a nice plane break on the front of that knee. But both legs don't face directly forward. This diagram shows that the legs arc around. The plane break on the knee at our right is in this position, whereas the plane break on the knee at our left is facing directly toward us. It's the same thing on the back. The plane break is at the heel, and its left leg is facing almost directly away from us. But the right leg is facing more to our right. So we analyze with forms that help us to see that. My student Ron Green invented this contraption to figure out how an animal leaps. Now that you know some anatomy, try your own variations on human and animal hind limbs. The only way to master drawing is to draw, but not always carefully. Quick gestural studies with pen and ink don't allow us to get fussy, erase, and fix. They protect us from creating belabored work that looks dead. Lines that go down moving and alive can better represent animals that are moving and alive. Legs support an animal. They propel it. They get it moving to find food or to keep from becoming food. They can be weapons. We've studied how they're made and shaped. Now we remind ourselves why they exist. A lever, a catapult, a spring, rear wheels, a bludgeon. Seeing legs for their functions reminds us why they're worth studying. Forelegs.